Hello. I wanted to do a quick show and tell of the scanner that I built for chapter 4 of the Crafting Interpreters book. What that is this program that when you run it, you can give it a string. So here's, it's not really a program, but it's just some nonsense. And it knows how to chunk that up into these kind of individual substrings, these lexemes that represent kind of atomic pieces of a program. And you can see it's identified them. And in some cases, it's figured out what the literal value is. So for that number, it's figured out that 42.0 is the value of the underlying number. So that's the program. I wanted to talk about, firstly, how the implementation works. And secondly, I wanted to talk about how I built it. It's just kind of a separate thing that might be interesting to some people. So firstly, let's have a look at the scanner itself. This is pretty similar to the implementation in the book, really, but there are a couple of differences. I would say the first difference is that I decided to separately deal with whitespace and comments. So in the book, there's just one case statement for reading a token, and it does all kinds of stuff to figure out if it reads a slash, for example, it then decides whether this is a slash operator or if it's the beginning of a comment. But I decided to separate that concern out. So I have this skip whitespace and comments method, which just completely deals with skipping over whitespace and skipping over comments before we even try to identify a token. So every time we call next token, first, phase 1 is to deal with whitespace and comments, and then phase 2 is to do the job of actually try to identify, well, now that we've got past all of the rubbish, what is the actual lexeme that we're going to try and read from the underlying string? So it's not an important difference, but for me, it makes it easier to understand what's going on here, because by the time we hit this case statement, we are definitely about to try to read a lexeme, and there's still this kind of fall-through case at the bottom that emits an error message if we didn't know what it was, but at least by the time we get to this part of the program, we're not still thinking about, what if the next character is whitespace or a comment, because we've kind of dispatched that separately. It's just a design decision, but for me, it makes it easier to understand what's going on here and how the scanner actually works. The second thing I wanted to point out was that once we have this line here is actually just peeking at the next character, it's not consuming it from the underlying text. So once we've seen that the next character is going to be a quote, for example, we call this read string token method. This is completely self-contained with respect to reading the underlying lexeme. So the first thing it does is it reads the opening quote, and then it sits in a loop and tries to read the rest of the string until it hits the closing quote, and then it reads that. So unlike the book, which kind of splits the responsibility of reading the string or the number or whatever between the top level, let's read the next character inside that next token method, and then the rest of the lexeme gets consumed by the kind of token type specific piece of code. Here, read string token is entirely responsible for reading the whole string. Read number token is responsible for reading the whole number. And again, that's just a design decision, but to me, it makes it easier to sort of think of these things as fully composable pieces rather than have this kind of slightly strange precondition where you sort of say, well, by the time we go into string token reading mode or number token reading mode, we've already read the first character of that string or that number. It's just a little bit more difficult for me to get my head around, so I kind of prefer it this way. The final thing that's different about this implementation is that whereas the book has us scanning a string and it has us returning an array of tokens, I have decided instead to have it return an enumerator of tokens. So this is kind of idiomatic for Ruby. I think that you can call this each token method on the scanner. If you give it a block, then it will yield a series of tokens to that block. If you don't give it a block, again, there's this kind of fairly idiomatic thing here of saying, I'm going to return an enumerator that knows to call this each token method. And then that gives you an object that you can call next on, or you can call each on to kind of get the tokens when you're ready for them. And sort of mirroring that, I suppose, I'm also treating the source as an enumerator of characters. So by calling each char on whatever source you pass in, which could be a string, or it could be a file, or a network socket or something, anything that supports each char, that will make the scanner kind of call next on that underlying enumerator as many times as necessary to produce each token. So you can almost make your way through the underlying source code on demand. As you pull tokens out of the enumerator that each token returns, it will advance through the underlying enumerator of characters and kind of read as many as it needs to be able to tell you, oh, okay, the next token is a string or a number or a keyword or whatever. So that's not a major difference, but just a sort of a slightly interesting one. Perhaps the thing that's most interesting about that is that if we look in the Ruby documentation, you can see that enumerator, which just is part of the core library, it lets you advance through the underlying enumerator, and it also lets you look ahead, but only by one position. So this lets, by calling peek on an enumerator, you can see what the next thing is going to be when you call next, but you can't look ahead any further than that. And that's a bit of a problem for this LOX scanner, because the lexical grammar of the LOX language requires 2 characters of look ahead. In the book, that's just used for numbers, so that when we read a dot after a digit, we need to know whether the character after it is another digit, in which case that's part of the same number, or if it's not a digit, then that means that the dot wasn't part of the number, it's just a separate dot. Maybe you're calling a method on a number or something. So to support that, we need to be able to peek 2 characters ahead, firstly to see if the next character is going to be a dot, and then see if the character after that is going to be a digit. And in my implementation, I actually need that to identify comments as well, because of that separation of concerns. If I see a slash is the next character, I actually want to peek 2 characters ahead to see if the one after that is also a slash, in which case that's a comment. If the next 2 characters are not slashes, then I don't want to do anything, because that's not a comment or white space that I can skip over, and I need to return so that the main case statement inside next token can do its job. So let me just demonstrate this. If I make an enumerator here, so let's say hello world each char. So that gives me an enumerator of the characters in that string, and I can use that peek method to sort of say, well, what would be the first character if I were to call next? And it'll say, well, that'll be an H. And then I can just iterate through this, HELLO space, and then I can say, well, what's the next character going to be? It's a W. So that works fine, but this doesn't have any way for me to say I want to peek, 2 characters ahead. Like, it just doesn't support that. So what I did was I implemented this look ahead iterator, which is an object that can wrap an enumerator. It doesn't care what it is, but I'm going to use it to wrap that enumerator of characters. And it allows you to, it's not really a full enumerator, which is why I called it iterator. It just lets you call next and peek on that object, and that will ultimately call next and peek on the underlying enumerator. But it also has this buffer in it that allows it to support look ahead. So if I say I want to peek ahead, this peek method here has got this optional look ahead keyword argument. So if I say I want to look ahead more than 0 characters, I guess this is 0 index. So if I wanted to look ahead 3 characters, I would pass in 2 here. It will fill up a buffer by iterating the underlying enumerator and putting the elements in a buffer as many times as it needs to be able to then peek and say, well, using the ability of the underlying enumerator to look 1 character ahead, I can now, I can tell you that the character coming up in 3 characters time is whatever. And the reason it fills a buffer is so that if you then subsequently say, well, I want to peek less far ahead than that, or more likely, I just want to call next and actually start to iterate through those characters, it's able to answer that question by draining the buffer or referring to the buffer, because the underlying enumerator has already forgotten about what those characters were, so we need to kind of remember them somewhere. So you can see that when I won't talk about this code in detail, but basically, if you try to peek ahead, it's going to fill up the buffer with some characters, and then when you say, I want to call next and actually iterate the underlying characters, if there's anything in the buffer, then first it will drain the characters out of the buffer, and then only when the buffer's empty will it allow you to then kind of go back to enumerating the underlying one. But this is all pretty transparent. So if I, let me see, if I do IRB minus ilib minus r lox, what's it called? Look ahead iterator. So now if I do this, like what I did before, but this time make a lox look ahead iterator.new hello world dot each char. So now I've got this look ahead iterator that's wrapping that underlying enumerator of characters. And I can do all the same stuff that I did before. I can peek and say, like, what's the next character? It's going to be an H. And that hasn't even touched the buffer, because it can answer that question just by asking the underlying enumerator, because it supports one character look ahead. And I can iterate as normal, so I can say HELLO space. Now if I peek, I can see the next character would be a W, and again, we haven't touched the buffer. But now if I said I want to peek with look ahead, and I want to look ahead, I guess ultimately 3 characters here, it'll give me R, and the way it's done that is by iterating the underlying enumerator until it's far enough ahead that it can peek to see what the following character is going to be. And in doing so, it's filled up, it's put a couple of characters into that buffer. So now this iterator and the underlying enumerator are in slightly different states. Like, we're still before the W of world, but the underlying enumerator has already advanced past that, and the buffer is kind of storing the difference between those two things. So now I can peek less than that. If I just want to look ahead 2 characters in this case, and it's answering that out of the buffer. If I peek ahead more, it's going to find that L, and it's found that by advancing the underlying enumerator another character. And then if I start advancing this iterator, it will give me a W, and you can see that has drained out of the buffer. I can advance again, it'll give me the O, that's drained out of the buffer. You get the idea. If I try to peek too far, it will do the idiomatic thing, which is it just returns this stop iteration. It raises a stop iteration exception, which is just coming from the underlying enumerator because I've tried to advance it past the end. So this has got effectively the same API as a subset of the public API of an enumerator, but it's got this extra power to be able to look ahead a bit further. So the way I'm using that is in the scanner, I wrap the underlying enumerator of characters in this look ahead iterator. And then that gives me the ability to peek into it when I want to. So next character method in this scanner has got this optional look ahead argument. So if I want to, I can pass that through. So if we look at most of these won't be using look ahead. So those ones aren't. But here, identifying comments, I am using look ahead. Again, only looking sort of 2 characters ahead actually. And similarly for digits, there's a place here where I'm looking 2 ahead. So actually, we don't really need the ability to do this arbitrary look ahead, but it felt like a kind of a nice, elegant solution to make that wrapper that allows us to do it arbitrarily, even if we only want to use 1 character, or 2 characters of look ahead in this scanner. So that's probably all there is to say about that. The other thing I wanted to talk about was how I implemented this. This is the repo that comes with the book, so this is like the official book repo. This contains a set of official tests. So I think this is tool bin test.dart, and I tell it I want to run the scanning test for chapter 4, and I tell it where my interpreter is. So my interpreter is in locks bin locks. So this is running a bunch of acceptance tests by sort of feeding a load of different strings into that executable and then verifying that the output is what it expected. So that's kind of useful, and I've used it to do a kind of outside-in sort of double loop TDD process for developing this implementation. So I've hooked these up to RSpec, so I can. Here, I've got an RSpec test that knows how to effectively just shell out to that Dart testing tool, but it's sort of integrated into the test suite of my implementation. So I can just say, firstly, I have to tell it where that is, so that it knows where to find that executable, and then I can just say bundle exec RSpec spec acceptance, and it will run that acceptance test, and then that's running Dart, running those tests and telling me that they're passing. So the way that I've used this, if I show you, the way that I've used this in my implementation is I kind of started out by running those acceptance tests and seeing how they failed. And then I've used those failures of the acceptance test to guide me towards what to implement next. And then as I've been implementing stuff, I've been writing unit tests to kind of flesh out the next piece of the system. And then I go back and see what the failure in the acceptance test is. And then I kind of bounce back and write more unit tests. So that's the double loop TDD. If I show you this in a bit more detail, here's where I began. The first time I ran the acceptance test, it's failing because that bin locks executable doesn't even output anything. So now we're getting this kind of missing output for everything it was expecting to see. So I needed to add some code here. This is only one line of code. And at this point, I'm kind of speculating about what do I want to be able to do? I would like there to be this lock CLI that I can instantiate and hook up to the standard input and the standard output, and then call a start method on it with the arguments. And then when I run the acceptance test again, now it's complaining that this lock CLI thing doesn't exist. So I needed to implement that. And so that's what I did. I've kind of fleshed out an implementation of lock CLI with the public API that I wanted it to have in the previous step. And I've written a bunch of unit tests to check that that does the right thing. I mean, in that case, not very much. In fact, maybe I can show you one of these in a bit more detail. So let's look at this, opening a REPL from the CLI. So at this stage, I was just using so this is something that the acceptance tests don't even try to do, but the book says you should have a REPL. So I cheated a little bit and sort of said, well, the acceptance criteria in the book say that we should be able to do this. So I've kind of added the ability to do this. If I maybe show you the CLI spec, you can see how this works. So I'm using verifying doubles here to kind of stand in for the implementations of things that I wish I had. So in this implementation, I'm doing things like saying, I'm going to need a logger, I'm going to need an interpreter, because I need to be able to call methods on those things to actually, in this case, run the source code. I haven't actually implemented those things yet, so I need to use these instance doubles to kind of stand in for them. And what's nice about this instance double thing is that once I've implemented that, if that constant is loaded, then RSpec will verify that any stubbing or mocking or whatever that I do on that test double matches up with the real public API of that thing. But at this stage, this isn't verifying anything. That class doesn't exist yet. I'm just pretending that it exists and, faking up the behavior that I want it to have. So I want to say, well, I should be able to call run on that interpreter, or I should be able to ask the logger whether it's errored. And then all of these tests just kind of exercise and drive out the implementation of this CLI class. And incidentally, they sort of design what the public API of that logger and that interpreter are supposed to be. So at this point, I can, what's it called? CLI spec. I can run the unit tests for this thing, and they all pass, even though the objects that it collaborates with haven't actually been implemented yet. So, this is maybe a slightly unusual way of working, but I really like it. Just to show off, one cool thing that I can do is just demonstrate that if I run through all of these commits and just run the test, you can see that all the tests remain green all the way through this. There's this pending test here is pending because I haven't told it where the book is. If I set that, crafting interpreters, then this time it's going to try to run the acceptance test on each commit, which is a bit slower, so I won't let it do all of this. But you can see it's kind of all the way through this, I've got these acceptance tests marked as pending, which tells RSpec that they're supposed to be failing. So it shows me the failure message, but it's like, it's okay that this is failing because you've said that it's pending. And in fact, if at any point these tests began to pass, that would actually cause my test suite to fail. So on the final commit of this thing, I have to flip a flag and say like, well, now that those acceptance tests aren't pending anymore, I expect them to pass. And then it can tell me that it's actually working as intended. So that's kind of nice. Let's, what shall I do next? Maybe, let me go back to that I'm nearly done with this, but let me go back to that commit I was looking at before. Well, maybe let's look at the next couple of ones, because I think that shows you a little bit of what I was talking about. So this was me sort of finishing the implementation of the CLI. If I move on to the next one, you can see at this point, I mean, I can actually run these acceptance tests and show you what the failure looks like. So this failure is complaining that there's no interpreter. Oh, maybe I've reorganized this code since I ran this. Oh no, sorry, this is this is the failure from before this change. So before I added this logger, the failure was that there's no logger. This commit implements the logger, so now the new one is telling me there's no interpreter. So yeah, I should have run the test on the previous commit to show you the motivation for having implemented this one, but this kind of, again, I'm just using rspec unit test to drive out the implementation of this logger, and then the next commit. Yeah, this is the error I was seeing before. There's no interpreter, and so this implements the interpreter. And again, the unit tests here are speculating that there's eventually going to need to be this thing called locks scanner, because the interpreter is pretty simple. It just instantiates a scanner and then calls each token on it. But we need that to actually exist at some point, but not yet. I can run this spec unit interpreter spec to check that my implementation of the interpreter is right. But obviously the acceptance tests aren't gonna run successfully because we're now missing the implementation of the scanner. And so that's the next thing that I do. So you get the idea. I'm just kind of using these acceptance tests to kind of tell me what to do next and tell me how to work on it. And then you can see now we're looking at the final commit. And here's the thing I was talking about. In the acceptance tests, I had to say those chapter 4 scanning acceptance tests are now no longer work in progress. They are done, so that when I run them, rspec doesn't complain about the fact that they pass. You know, it's expecting them to pass. So that was kind of a fun and interesting way to approach it. And that's it. If you're interested in this, it's all up on GitHub on, what is it? github.com/tomstewart/locks. I think hopefully all of the commits are fairly self-explanatory, but I've written quite a lot of, get rid of the patch. I've written quite a lot of explanation in the commit messages. So if you're interested in how any of this works, then go ahead and have a look at it. I hope that'll be interesting to you. Well, that was it. Thanks for watching. Bye.